So question 21 says to rewrite the quadratic function in standard form by completing the square. And we have the following function. Now there are a couple rules when completing the square. The first and main rule is that in order to complete the square, the leading coefficient must be 1. So we're going to divide both sides by 2. And then we're just going to simplify over here. The second step is to move the constant to the other side. So those cancel out. So now we got f of x over 2 minus 17 over 2. Once you get to this step, it's pretty basic. You just got to remember the steps to complete the square, which is to take half of this number and square it. And then we're going to add that to both sides. Okay, so that's going to wind up giving us f of x over 2. Let's see, this will be 18 over 2, so it's going to be plus a half equals. And then we're going to go ahead and complete the square over here. This is a perfect square trinomial. It's just x minus 3 squared, which is how vertex form works. This is the h for the vertex. We're going to subtract our 1/2 to both sides, so we can just get this back to a simple equation with f of x. And then you got one more step, because you're dividing by 2 over here. You want to multiply everything by 2. So you wind up with f of x equals 2 times x minus 3 squared minus 1. You don't do anything inside parentheses because order of operations tells us we have to do that squared first. So that would be the equation in vertex form by completing the square. Alright, next 22 is very similar. It has, except it gives you a point, so the vertex, which is going to be 9, -7, and it gives you a point. Well, if you remember what the equation for vertex form is, and I'm using vertex form momentarily because I'm given the vertex, it is f of x equals a times x minus h squared plus k. Well, f of x and x are just the point. H and k are vertex, so we're missing our a, so we're going to try to solve for a here first, because we can't do anything without that a. Alright, so then we're just going to break some things down, simplify, and that's going to give us our a. And we're going to go ahead and add our 7 to both sides, so we get 45 equals 9a. Okay, and we're going to divide by 9, and we notice that a is equal to 5. Well, you're still not done, because if you read the question, it says find the standard form. Okay, so standard form is ax squared plus bx plus c. So vertex form won't work, but we can use vertex form to go to here. So we're going to go ahead and start with vertex form. We know what a is now. It's 5. We don't do anything with x because we're trying to put it in standard form now. Okay. Now from here it's real simple to put in standard form. This portion here we're just going to FOIL, and if you can just do it in your head you can, or you can FOIL it out. I'm going to go ahead and draw the arrows just in case you need them. Okay, this is a difference of, a perfect square trinomial. So you get 5 times x squared minus 18x plus 81 minus 7 at the end. And then we're going to distribute our 5. So we got to get rid of these parentheses, and we get 5x squared minus 90x and then plus 405 minus 7. And then combine what's in common here, so you get 5x squared minus 90x, okay, minus 390, plus 398. And that is our equation in standard form instead of vertex form. Okay. 23 was actually one of the easiest problems on the test. It gives you a function h of t, and it tells you that this is equal to 16t squared plus 24t plus 150. And then the first question, part A, says how many seconds will it take for the rock to reach its maximum height? Well, since we're talking about the maximum height, maxes and mins rotate around the vertex. So we want to find the vertex. And the good news is there is a formula for the vertex in standard form. Now, we're going to improvise it a little bit, obviously, because, we got negative b over 2a. That gives my h. And then we're just going to substitute that back into the original equation, and that's going to give us our k. So we're just going to find b, which is located beside the linear term. So we got negative 24 divided by 2 times negative 16. So that's going to give us a negative 24 over negative 32, and this is going to be 3/4. Okay, but since we're doing applications, we can't say 3/4. We have to say 0.75 seconds. Okay, that's part A, or part A, and then there's the next part. It says height. Well, if we found the seconds it took to find the height, we're just going to take this value right here and we're going to substitute it into the original equation to determine what that maximum height actually was. And if we type this in our calculator, we are going to get 159 feet. Okay, it's 159 feet. And then part B says, when will it hit the water? Well, if we consider water or ground as the x-axis, this means find the zeros. And if you look at that equation up there, you can't really factor it, so we're going to use the quadratic formula, okay, which is x is equal to opposite b plus or minus square root b squared minus 4ac all over 2a. And we're just going to substitute our values in. We got opposite of b, which could be negative 24, plus or minus square root. Okay, we got 24 squared minus 4 times negative 16 times 150, and then all over 2 times negative 16. And then we're just going to actually work through this. We get negative 24 plus or minus. You could type this part in your calculator. I'm just going to break it all down. That's going to be a plus now. And then that's what we're going to come up with at first. And then we're going to go ahead and put this as decimal form because we're talking about applications. So I'm going to go ahead and write the decimal down. So this is going to be plus or minus 100.9 all divided by negative 32. And then you have two equations here, so you want to break them into two pieces. So we can do negative 24 plus 100.9 over negative 32, which is equal to which is going to be a negative 2.4, which we know can't work because application time cannot be negative. And so we'll do the other side, which is going to be negative 24 minus 100.9 over negative 32, and we'll see what we get there. And we get 3.9. So it would take 3.9 seconds to hit the water. Okay, and that's 23. A little bit long, but it's not that bad. Especially if you remember those two formulas, it's real easy. Alright, 24 is real simple. You have the equation, and it tells you to state the zeros and the multiplicity. Well, the zeros are simple. You just take each section and set it equal to 0, and that will give you your zeros. Okay, so just like that, so you get x is equal to 0, x is equal to -4, x is equal to 5. That's the zeros. And then your multiplicity is just the exponents. So we got a multiplicity of 6, we got a multiplicity of 3, a multiplicity of 2. And that's it. That's all you had to do for number 24. And then 25 was very similar. It says you have zeros of -8, 0, with a multiplicity of 4, and 6. So you got 3 zeros here. So we want to convert these to factors because we're trying to get a polynomial of minimum degree. So -8 turns into the factor x plus 8. 6 turns into factor x minus 6. And then 0 is just x. And since it has a multiplicity of 4, we're going to put the exponent of 4 attached to it. And that is pretty much it on 25. Okay, 26 is all about long division, so we're going to take our factor. I got ant crawling on me. And we're going to use long division to divide that factor into this polynomial right here. And the key to these is always to keep them in numerical order from highest degree to lowest degree. Alright, so first thing we do, we want to look at the first number. And we'll look at the first part of the factor. How do we multiply from 3 to get to 18? Well, that's simple. It's 6. Now you have to look at the variable. How do you multiply from x to x to the fourth? Well, you need 3 of them. Once you get your value, you distribute it to each piece of your factor. So you got 18 x to the fourth plus 6x cubed. But we're always subtracting this quantity here. Okay, so those cancel. You get 24 minus 6x squared. That's going to be 18x cubed. I'm going to go ahead and drop down everything. It's just what I like to do. You don't have to drop it down every time like this. It's just my personal preference. And then same thing here. Well, that one's pretty easy because it's the same as the first one, except we need 3 now instead of 4, so it's just going to be 6x squared. So we're going to get 18x cubed plus 6x squared. And remember, we're always subtracting whatever we get. These cancel. So we got 12 minus 6, that's going to be 6x squared. I'm going to drop down everything again. Okay. And then now I want to look at something different. How did I go from 3x to 6x squared? Well, that's by multiplying by 2x. So we get 6x squared plus 2x. And we'll subtract that whole quantity there. So those cancel, and we get 9x plus 3. Well, how do you go from 3x to 9x? You multiply by 3. Let's see if this works out. We get 9x plus 3, and look at that. Remainder of 0. So this answer has to be, that's my quotient right there. 6x cubed plus 6x squared plus 2x plus 3. That's the quotient. Okay. Alright, 27. We're almost done. That's the good news. Alright, 27, given that -2 is 0, the polynomial, x cubed plus 11x squared plus 30x plus 40, determine all other zeros. So since it says determine all other zeros, we want to use synthetic division so that we can determine what the quadratic is going to be, so we can factor that and determine the zeros. That's the easiest way to do this. So we're going to drop our 1, we're going to multiply, add those together, we're going to multiply, add those together, we're going to multiply, add those together. So what we have here is that we have the quadratic x squared plus 9x plus 20. And we want to factor this. So it factors what multiplies to 20 to get 9. Well, we got 1 and 20, that doesn't work. 2 and 10, that doesn't work. 5 and 4, oh perfect. 5 plus 4 is 9. So we got plus 5 plus 4. Okay? So the first part of this says determine all other zeros. This does not tell me the zeros. Determine the other zeros is when you take and you say x is equal to -5, x is equal to -4. That's determining the other zeros. So that's half this question right there. And then the second part says write the polynomial in terms of a product of linear factors. So we got p of x equals, and we'll do linear factors. The first zero was -2, so we're going to change that to x plus 2. And then the good news is we already have our next two factors. So we can just write those down, and that's the second part of your problem, and you're finished. Alright, 28. Last page. Alright, 28 says using Descartes' rule to determine possible number of positive reals and negative reals. So you have p of x equals 2x to the 5th plus 5x to the 4th minus 7x minus 4. And it says we wanted to use Descartes' rule. So Descartes' rule says that we have to do a negative x for the negative one. So we're going to go ahead and do this. A negative x to the 5th is going to be a negative number. A negative x to the 4th is going to be a positive number. A negative times a negative is going to be a positive, and then there's a negative at the end. So now that we got them both, we can set up our chart. Positive, negative, imaginary, total. You don't actually have to do the imaginary on this one, but I personally like to, so I'm going to go ahead and fill out the chart. So if we look at positive, let's see what we have here. You have one sign change, so there's one positive. Okay, and then let's go down here and take a look at our negative. We got a sign change here, and then we have a sign change here. So we can have two negatives, but because of Descartes' rule, we also can do an even number, subtract an even number from that, and that's it. So we can have 2 or 0. So in reality, you can really put your positive is 1 and your negative is 2 or 0. Just like that. And that's how you can write this answer, because that's all it's actually asking for. No, you're okay. You test?
I don't know.
Yeah, that's fine.
Sorry about it. I just don't feel ready today.
That's fine.
I'm gonna let you speak now.
You're okay.
What are you doing?
I'm doing a test. Alright, question 29, which is the last question on the test. It's a two-parter, but each part counts as a question. You have the equation p of x equals 6x cubed plus 17x squared plus x minus 10. And the first part, 29, says, part A, use Descartes' rule to determine possible combinations. Combinations means that you have to do the chart we practiced in class. So let's go ahead and write our p of negative x up here so that we can take a look at both. It's going to be a negative 6x cubed. It's going to be a plus 17x squared minus x minus 10. Now let's go ahead and set up our chart. Positive, negative, imaginary, total. Because since we're talking about combinations, we have to show how they go together. Alright, so positive, see how many sign changes we have. Well, on positive, we only have one sign change. So we can only have one positive. On negative, you have one sign change, you have two sign changes. So you can have 2 or 0. So that means you can still have one positive here. It means there will be 0 imaginary, 2 imaginary, for a total of 3 in each. That's part A, using Descartes' rule. Okay. Part B says use the rational root theorem. Well, the rational root theorem needs the leading coefficient, which is 6, and needs the constant, which is 10. Okay, it doesn't matter if you write negative, 10, or positive. You're still going to do plus or minus on the factors. So here our factors are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And then for 10, we have plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Okay, and then the rational root theorem rule says we're going to do the constant divided by the leading coefficient. So let's start here. Okay, constant over leading coefficient, we got 1 over 1, so that's just 1. We got 1 over 2, so that's 1/2. We got 1 over 3, that's 1/3. We got 1 over 6, that's 1/6. Then we start with the 2. We got 2 over 1, that's 2. We got 2 over 2, which is just 1, so we're not going to rewrite that one. Okay. Then we got 2 over 3. And then we got 2 over 6, but if you simplify 2 over 6 down, you get 1 over 3. We're not going to write that again. We never write duplicates. So then we got 5. We got 5 over 1, which is 5. We got 5 over 2. Okay. And then we got 5 over 3, which all work. And then we got 5 over 6. So none of those repeated. Then we do 10. We got 10 over 1, which is just 10. Okay, we got 10 over 2, which is 5. We got 10 over 3. And then lastly, we got 10 over 6. But 10 over 6 will go to 5 over 3. So these are all my possible rational roots. You have to get every single one of these right and not add any extras to receive full credit on this part of the question. Okay. Now, number 30, it says test for the rational roots and then factors product of linear and or irreducible quadratic factors. So the thing is, we need to figure out which of these is a 0. So what you can do is there are multiple ways. I suggest, because we have so many zeros that we actually have to test, that you may want to use the remainder theorem and substitute them in until you get the correct one. Now I'm going to go ahead and show you one that works, and that's -1. Okay, -1 is going to work. So we're going to drop down all of our factors, our coefficients. And I'm going to show you that -1 works just to save on time. You can test these however you want till you find one. So we're going to multiply, add those together, multiply, add those together, multiply, add those together. So we do see -1 is a 0, and we get the quadratic 6x squared plus 11x minus 10. Okay. And then we want to try to factor this out, okay, which really isn't that difficult. The hard part is you have a 6 here, so you've got to take into account that 6 can either be 1 and 6 or 3 and 2. And then your 10 can be 1 and 10 or 2 and 5. So we want to see if there's a combination of the two that works. Okay, you can do guess and check. You can use diamond method. It's really your preference on how you want to solve this, okay? But I'm going to go ahead and tell you that 3 and 2 are going to work. So it's actually going to be 3x plus 2 and 2x minus 5. Okay, what you got here is 3 times... No, I totally did it backwards. I'm sorry. Okay, now we got it right. Okay. What we got here is we want our larger number that we multiply to be positive because our 11 is positive. Alright? So if we got 3 times 5, that's 15. -2 times 2 is -4. 15 minus 4 is 11. And -2 times 5 is -10. You can use however you want to find this. If you want to use the diamond method, you go ahead and use the diamond method. It's totally your choice. Okay? So now we're done. It doesn't tell us to state the zeros. It just says to factor the equation as a product of linear terms or irreducible quadratics. So we know the first one's x plus 1. The second one is 3x minus 2. And that third one is 2x plus 5. And then I'm finished. Okay. And that's how you complete this test. And that's how you do every single problem. Now, I will go back here. I'm going to go ahead and do the diamond method just for those who need it. So if you were doing the 6x squared plus 11x minus 10, the diamond method is very simple to use. You take the first two numbers, the first and last number, and multiply them to the top. Then you take the middle number and put it on the bottom. And then we're going to try to figure out something that multiplies to 60 and adds to 11. So I'm going to start going through my head and thinking multiples of 60. We got 1 and 60. No. We got 1 and 60. Doesn't work. We got 2 and 30. Doesn't work. We got 3 and 20. Doesn't work. We got 4 and 15. Oh, look at there. 4 and 15. That's perfect. Okay, but we want a negative here. Alright. So how are we going to multiply to negative there? Well, we want the bigger number to be positive and the smaller number to be a negative. That's going to add to a positive 11, multiply to negative 60. Okay. So then, once you get these, you just rewrite the equation using those values. And then we're going to group and put a plus sign in the middle. Okay. So what's in common here? Well, we got 3x in common here. And that's going to give us x plus 5. 2x plus 5. Sorry. It's 2x plus 5 there. Running out of space here. Alright, and then over here we're going to do the same thing. What can we pull out here? Well, we can pull out a negative 2. And that's going to leave us a 2x plus 5. Remember, what's inside these parentheses here has to be the same thing. So that's going to give us a 3x minus 2, 2x plus 5. That we came up with up here. Okay, and that's how you work this entire test.